Yes, I am. Thanks.
Yes. So I am stop sharing the screen. Now your turn.
Okay, just give me a sec. Um, you should see my screen now. Um,
Not yet.
Not yet.
You should click once again, screen sharing, and then choose the window.
So let me try once again.
Yeah, sure.
Screen on. Is it better
Yep.
now?
Yes, we see it. And last question before we start, the questions during, somewhere in the middle, at the end, in the Q&A session.
Yeah, so feel free to ask questions anytime you want. I will try to answer them depending on how many we have.
Okay.
We can leave that also to the end of the session if there are
Okay,
too many.
so let's agree that me and Philip, we will moderate it a little bit. So if you have any questions during the presentation, let's write it on the chat. If you would like to ask directly, please wait until the end of the presentation, and there will be a Q&A session, and you can open discussion, let's say, about the DataOps and the deployments of analytic applications. So once again, thank you, Łukasz. Stage is yours.
Thanks a lot. So first of all, thanks for having me here and thanks for joining the meeting. My name is Łukasz Olejniczak. I work for DataOps Technology, where I am a member of engineering team. And at the same time, I help our clients as cloud solutions architect. So my presentation is entitled Applied DataOps, and I will focus mainly on automated deployments of analytics applications. I'm not selling anything here. Rather, I would like to share with you some concepts and would really appreciate hearing your feedback. So from what from this from the question that was asked on chat, I understand that at least some of you are familiar with Azure. I also saw that other people are using just different clouds. We forgot to ask about whether you guys have some experience or are trying to automate deployments, whether it's part of your job or so. But for those of you that are new to this topic, I will try to explain also some foundations. Okay, so my presentation is divided into two parts. The first one is introduction, and then there will be a short demo. More detailed agenda is as follows. So first, I will touch briefly on some basics. It will not be a deeper dive, rather an opportunity for me to explain glossary, which I will be using quite often in this presentation. Then I will try to show how automated deployments can help to accelerate delivery of business value. Next, I will move to the main part of this presentation and discuss some foundations on design principles behind the framework, which we call DataOps Assembly. And this framework is used to generalize and then automate deployments of analytics applications. Then I will show how it all may work. So there'll be a short demo of this framework. And finally, I will present some challenges that you may face if you would like to build such framework in your organization. So first things first. In the title, I use the term analytics application. So let me explain first what it is by contrasting it with traditional applications built by software engineers. For me, the main difference is that analytics applications in general utilize many different components like ETL server, data warehouse engine, reporting tools, machine learning, and model serving infrastructure. There are many moving pieces, and therefore things like testing, deployments, etc. are quite challenging. When it comes to analytics, people quite often break it into three streams. One is descriptive analytics, which covers more traditional business intelligence use cases and is focused mainly on the past. Predictive analytics, as the name suggests, is focused more on predictions. And prescriptive analytics is when we are able to be presented some recommendations, some specific actions that we should take to, for example, optimize our revenue, etc. Regardless of which stream is closest to you, I think those challenges around system complexity, testing, and deployments are quite generic. Also, I think that we can assume that all such projects output something which is broader known as data products. And regardless of how sophisticated these solutions are, data product is just a collection of database scripts, ETL pipeline definitions, machine learning model training pipeline definitions, notebooks, report definitions, etc. So all that is needed to solve some business problem with data. Because this presentation is focused on deployments, and whenever we talk about deployments, we mean deployment of applications, I will use the term analytics application and not data product. Analytics application as a set of scripts does not yet bring any value to our business. It is something that is yet with development team, waiting to be released, to start breathing, become integral part of organization production ecosystem, and have impact on our business. Therefore, some additional effort is needed to convert those outputs or scripts, technology into business outcomes. And this is somehow pictured here on the slide, which shows analytics application lifecycle. We typically start with some experiments. Given business challenge, we try to find appropriate data sets, run some ad hoc queries, profile the data, train the model, etc. Implementation is the next phase. And here is where we implement ETL and machine learning pipelines, database scripts. This is the stage where we test our solution, and then we package our end product. So, this end product is something that must be released, and once released, it transitions into operations, where operations teams or platform admins monitor different aspects. Okay, in this phase, we also have a chance to hear from our users how this application is aligned with their expectations so that we can measure those business outcomes. And converting technology outputs into business outcomes is nothing specific to analytics teams. Software engineers have faced it years ago, and I think we all would agree that they simply master this topic to the extent that other IT professionals are trying to copy their methods. Therefore, concepts like Agile, DevOps, CI/CD are becoming the new normal also in analytics domain. Data practitioners simply face similar challenges, but software here is used more to transition data from one state to another, but it is really all about data. Hence the concept called DataOps. And there are many definitions, but the common denominator is that DataOps takes a lot after DevOps and tries to implement similar practices to both data and software that processes that data. So DataOps addresses data quality issues and tries to reduce cycle times. Therefore, teams practicing DataOps should become as flexible as if it was a startup, and yet solutions they build should be as reliable as if they were produced in a factory. Of course, we have strong influence of agile values, especially to prioritize by business value and reduce obstacles that impact delivery of that business value. So let's look once again at analytics application lifecycle and see which stages can be optimized to reduce that cycle times. In experimentation, probably we spend most time trying to find appropriate data sets. In implementation, we can, of course, implement faster, find more flexible data models, etc. But my experience shows that it is the moment when teams have to release the application that is the main bottleneck. Application teams are focused on building great solutions, but consider deployments and then operations and something distant and granted. So this presentation is about optimizing optimizing delivery of business value in this stage. So what is needed to deploy application, at least from technical point of view? So first we need analytics platform. Analytics platform represents infrastructure. It is a group of services which collectively function as a platform. So it's ETL engine, it's a data warehousing engine, it's visualization tools, model serving tools, etc. Then we need to ask platform administrators to apply some configurations so that we can land our application there. We need some space on the platform, and only platform admins have necessary privileges to prepare it for us. I will use the term application environment for this. And once the application environment is prepared, we can deploy our application artifacts, ETL pipelines or ETL server, database scripts on data warehousing engine, notebooks, etc. And as you can see, a single platform can host many applications. So let's spend just a second on platforms. If we check DataOps manifesto, which is available on this link, then there is one principle that states that it may be sensible to allow users to experiment in isolated temporal environments, which should reflect production. The main motivation here is to encourage experimentation and yet reduce blast radius. It is therefore reasonable to agree on some analytics platform architecture blueprint, which then can be scripted so that we should be able to use the same script multiple times and provision multiple identical environments. It may be a bit challenging on-premises, but it is rather straightforward on public clouds. And the concept infrastructure as a service applies nicely here. There are many tools or libraries that support such an approach, like Terraform as an example. And here on this slide, we have just example of such platform architecture blueprint, which I will use in my demo. Let's assume we are Acme company. Acme decided to use Azure Cloud, and analytics platform architects have designed blueprint to be used as default option for all solutioning teams. As I said, this is just an example. For sure, there is something missing. There may be better choices. It doesn't matter here. But in this particular case, Acme decided to have platform architecture blueprint with Azure Data Lake for storage, with Databricks for data engineering, machine learning with Spark, Azure Data Factory as orchestrator, and Snowflake as a final data warehousing service. We also have Azure Key Vault service to store our secrets, Azure Log Analytics Workspace for centralized logging, and Azure Active Directory for identity and access management. For real-time use cases, we would like our teams to use Azure Event Hub and Stream Analytics jobs. So Acme platform admins I all agreed on this architecture and then implemented, for example, Terraform script. So they are able to quickly provision platforms with all those services provisioned. Okay, so just for our demo, let me go to our platform where I have created something which is referred in my presentation as analytics platform. So it is a set of services that collectively function as a platform. So we have Azure Data Factory, Azure Data Lake, Databricks, Key Vault, Log Analytics Workspace, and we have also a Snowflake account. Okay. This platform is empty. I will not open the services to prove it, but it's a fresh environment. Okay, so with scripted platform blueprint, we can have static environments like UAT, production, test, etc. But platform administrators can also provision additional on-demand disposable environments, as it is specified in DataOps manifesto. And if we need such flexibility, then networking architecture may be quite important. And here on this slide, we see so-called hub and spoke architecture. Our on-prem network is paired with central virtual network on cloud. This blue rectangle represents cloud. This central virtual network is called hub, and that hub is then paired with many so-called spokes. And as you see, every spoke is a single platform instance of a single environment. The central hub is a great place for CI/CD server. From here, we will be trying to execute all our automation scripts, eventually deploy our analytics applications, represented here as orange boxes. Okay, so to deploy application, we need platform, but then we also need some isolated space on that platform for our application, something which I called application environment. Setting up application environment includes all the steps that normally are executed by admins. So let's have a closer look at one of the platform components, and let it be Databricks, for example. So our platform automation script will just create Databricks workspace. Then for application environment, we need platform admins to create service principal for our application in Azure Active Directory. We will use that service principal to run our scheduled jobs. So we don't need to run jobs using our corporate credentials. This service principal must be imported to Databricks workspace. We need Databricks security groups for the application to control access by groups. We need to apply so-called entitlements to those security groups. Create folder, which is like container where we will place all application and notebooks, etc. So it even sounds like lots of things that are in general configured by admins and not project teams. Of course, our platform consists of many components, not just Databricks. So we have Snowflake, Data Factory, Data Lake, Key Vault, etc. And every such component requires similar actions, similar admin configurations, which will strengthen security. When the application environment is ready, we are good to import our application code, our application artifacts. So if we focus only on Databricks component, we need to, for example, import notebooks to a folder that was prepared for us when setting up application environment. In this presentation, I will not talk about platforms or platform automation. Platform is mandatory to deploy application, and I will assume we have it whenever we need it. Instead, I will focus just on application piece. So I will try to show how we can accelerate delivery of business value by automating configuration of application environments and automating deployments of application code. Okay, so when we get back for a second to DataOps manifesto, there is another principle called analytics is code. And it states that analytics teams use a variety of tools to access, integrate, model, and visualize data. And each of those tools or services generates code and configuration. Okay, so we have a lot of code and configuration when we develop our analytics applications. So how software engineers handle application deployments? And most of you would probably answer that they use containers, Docker or such like. And indeed, containers are extremely helpful here. They help to set up sandboxed view of the operating system that is isolated from other applications. And the concept of build once and run everywhere is not just marketing. It just works this way. So if we compare, that with our analytics ecosystem, then we can see that where traditional containerized applications are hosted on Docker engine, our analytics apps are hosted on analytics platform. And one comment here, sure, some of our analytics platform services can be containerized, but you are not interested in containerized platforms, but in containerized workloads, okay? So not all analytics workloads can be executed as containers. It may be our conscious strategic decision not to bother with administration of container orchestrators and rely more on platform as a service or software as a service options. For example, Databricks and Snowflake are both examples of such. Or simply, components we use are not there yet. Think about, for example, Informatica, Power Center, ETL processes. We cannot containerize them, and yet the tool is quite powerful. Okay, so advantages of containers are really strong. Also, when we take into account how simple it is in general to deploy new versions of containerized applications. So question is, how to achieve something similar when containerization is not an option? And framework, which I will present in a minute, is just about that. It tries to achieve that flexibility through automation. But automation alone is not enough, okay? And to justify that statement, let's consider the most popular application release models. First one, we can characterize as based on manual ad hoc deployments. When application team tries to release changes, they create Jira ticket to different administration units, to ETL server admins to release ETL code, to database admins to release database scripts. This model is typical for highly regulated organizations and is justified by complex security requirements. However, when it comes to organization agility, it has many flaws. Release takes a lot of time, is unpredictable, steps are in general handled manually, and therefore such deployments are prone to errors. It all takes time, so business must really exercise patience. Another model with automated, decentralized deployments is the most popular nowadays, especially in organizations on so-called agile transformation journey. In that model, application teams practice DevOps practices and have automated deployments with continuous integration and continuous pipelines and continuous deployment pipelines. Issues that I see quite often are the following. This automation applies mainly to deployment of application code, while configuration of application environments, that security box that we need to deploy our code, is still quite lengthy process and in general resembles the previous model. Second issue is that application team, given a task to automate their deployments, have additional tasks in their backlog, which are about implementing those automation scripts, bug fixing and improving them. Also, there is very limited reusability of what was implemented by other teams. Effectively, every team is trying to some extent to reinvent the wheel, trying to figure out how to implement, for example, version control for database scripts, or version control deployment of ETL code in Azure Data Factory. When they implement those scripts, they introduce different naming conventions, etc. And finally, operations or platform admin teams have really hard time trying to figure out what is happening given all those CI/CD pipelines are really everywhere. So given all those issues, we can think about slightly improved model, which is described as automated deployments from shared automation scripts owned by operational platform admin teams. Kind of deployment reliability engineers. And the framework I will be presenting in a second is exactly about having shared automation scripts that are used by many application teams. Such an approach should give application teams more time for implementing business features and spend less time just implementing automation scripts. Also, if we really want to reduce cycle times, we should try to automate both. Not only deployment of application code, but also configuration of application environments so that we can experiment faster. So let me introduce this framework, which we call DataOps Assembly. And here is how it works. So let's assume we have application team which consists of Snowflake, Databricks, and Azure Data Factory developers. Platform admins created environment for that team, and they started to work on business features. Snowflake developers will create database scripts. Databricks developers will implement Spark code, ETL pipelines, machine learning models, etc. Azure Data Factory developers will implement orchestrating pipelines. All those tools generate code and configuration, but all of this must be snapshotted together to represent application version. So once all those scripts are done, application team must package them, and the package is then handed over to this black box, which is our framework, and that framework has scripted know-how on how to deploy different parts of the application on target platform. It is like post office, which scans incoming packages for stamp to learn where to deliver this package. And at the same time, it works as a factory or assembly line where different floors or modules have all the know-how needed to deploy that application. In terms of continuous integration, continuous deployment, application team is owning continuous integration when they test the solution and package it. DataOps Assembly is part of continuous deployment pipeline. So DataOps Assembly basically needs two inputs: information what to deploy, so our application code, and information where to deploy, so information on which platform that should be deployed. So I will talk about that a bit later, but this framework is implemented in Ansible, so running it is as simple as running Ansible playbook with two parameters representing references to our application code, installation package path, and configuration file describing target platform, so platform config file. So let me switch to our continuous integration CI/CD server and just run the script. We'll continue the presentation, but as you see, I just ran install changes from one of the modules of DataOps Assembly. I provide the installation package, which is the path to the code of my application. I also provide the location of a file describing the platform on which I want to deploy it. And that's all I need. So as I said, this script needs like 10 minutes to complete. Okay, so let's get back to our presentation. Okay, so configuration file describing target platform is called platform descriptor. Platform descriptor is YAML file which lists all available platform components with some additional basic details, and those details will be used by the framework to connect to that service. Please note that there are no secrets. It's a plain text without sensitive information. Secrets are stored in Azure Key Vault, and the platform descriptor just includes the corresponding secrets names. For example, here we have a section describing Snowflake account. So we have account name and two secret names representing Snowflake account admin secret and Snowflake account admin password. So based on those names, DataOps Assembly will fetch the corresponding secrets from Key Vault. Okay. Okay, so the platform is implemented based on that architecture blueprint, which I discussed a few minutes ago. So that platform has all the services that were listed on that blueprint. So we have Databricks, we have Key Vault, we have Data Lake, Azure Data Lake of second generation, we have Azure Data Factory, and we have Snowflake. And from practical point of view, it's best when such descriptor is generated by platform automation scripts when we provision this platform. Okay, so that we don't need to generate that manually. This file helps us to decouple application code from platform. So in our we don't have any specifics about the platform, neither in our application code nor DataOps Assembly, although the framework doesn't know anything about the platform on which it will be described. All the details are provided by this configuration file. And this decoupling of application code and platform brings us closer to having possibility to build the application once and deploy it whenever we want. So this what Docker states, build once, run everywhere, right? Okay, so the next design principle behind our framework is that because we want this framework to be a shared asset, okay, used by many application teams, we must somehow generalize how those application teams organize their code. So we defined a generic format for packaging application code. We call it installation package format. It's a very similar approach to MLflow projects module, which also tries to standardize how people package machine learning code. So we introduced very simple conventions. For example, Azure Data Factory code, which is our orchestrator, pipeline orchestrator, are placed inside ADF folder. Databricks notebooks are placed inside Databricks folder. And database scripts are placed inside SQL folder. And thanks to such simple conventions, DataOps Assembly knows where to find code to be deployed to different platform components. We also introduced the concept of profile files. Profiles, those who have something to do with software engineering know this concept very well. Profiles are YAML files which include all the configuration of our application. So profiles are useful if you want to deploy our application from the same code, but with slightly different configurations. So in that case, we just need to have two different profile files and instruct DataOps Assembly to use it. One example is that we may need in test environment a smaller Databricks class Spark cluster than it will be needed in production. Okay, and finally we have some file called app YAML. it's like application ID card. It is yet another YAML file, but it contains only static information like application name, who's the owner, etc. Okay, so generalizing how people package application code is needed because we want this framework to be used by many teams. But we also want this to have possibility to deploy this package everywhere, on every platform. Assuming that we're talking about platforms deployed from our architecture blueprint. What it means for our application? It means that the code, our application code must be parameterized so that it is almost like application template, and corresponding values must be calculated at runtime. That is when DataOps Assembly runs actual deployment or actual installation. If we hard-coded configuration details in our application code, like database names, etc., our application will not work if we deploy it on different platforms. So when DataOps Assembly runs, it first builds something which is called execution context from variety of inputs. One of the inputs is platform descriptor, which provide parameters about platform components. There is application identifier, which will provide application name. And that application name can be used to build, for example, unique names for that application, unique names for Active Directory groups that will be created for this application. These parameters are added again to the context, okay, and can be used to compile application profile file, which represents configuration of the application and simply is yet another template. Compilation simply means DataOps Assembly will inject parameter values when there are placeholders for such values. So profile parameters are then added to the context again and can be used downstream to materialize or to compile other templatized application code. But this is probably the most important requirement if we want to have portable applications. Application code must be parameterized. So we have abstracted platforms, target platforms with platform descriptors, and generalized how teams package application code, introducing set of conventions known as installation package format. We enforce application code parameterization and calculate parameter values at runtime. Last thing is about how DataOps Assembly, how this framework handles configuration of analytics application environments. So those security boxes. In DataOps Assembly framework, we decided to break the code into two modules. One to be executed by platform administrators, which handles configuration of application environment. Simply, only platform administrators have all the necessary privileges to do it. The only advantage of this framework is that it automates those steps. And the second module is exactly about deploying application artifacts. All the steps that are needed to configure application environment are externalized into such YAML file. So there's yet another YAML file, which we call security module. This YAML file this time is part of DataOps Assembly framework. But instead of hard coding those rules, those security rules, they are externalized to YAML file. And motivation here is that it is much easier to customize this security model by just modifying the YAML file than changing the automation code. There are well above 100 steps that require admin privileges to be executed for every application environment. So for example, if we read it, for every application environment, DataOps Assembly will create a set of Azure Active Directory groups. The names are parameterized, and this context application identifier variable is calculated at runtime from application identifiers. Okay, so we have that name, and from that name there'll be a derived value. So for that application, for every application environments, we have a different set of Active Directory groups. So we having Active Directory groups, we will be able to assign users and manage access to that application by Active Directory groups. Every application environment will also get service principal. And that service principal, as you see, will become contributor of that application. And there are many more. We will not dive deep here, but there are rules for every single platform component. So the model is consistent across all those components. The security model, once agreed, is applied to all application environments. As I said, this is part of the framework, which means it definitely standardizes how application environments are configured. And at the same time, it works as informal contract between development and application teams. So developers know how application environments are secured so that they can design their solutions that comply with this security model. And operations and platform admins are ensured that their recommendations are enforced. Okay. So this slide is kind of a requirement for such framework. So as I said, we have a possibility to automate application configuration of application environments. We have a code that automates deployment of application code, but installation is not just enough. We also need to have possibility to roll back both application code and leave our application environment untouched. But you also may want to decommission our application environment so that other teams can use platform resources. Finally, DataOps Assembly was designed to support release models where automation code is reused, where it is a shared asset. We have therefore implemented it in Ansible, mainly because Ansible is very easy to learn. It's almost declarative language with quite flat learning curve. And why is it important? There are three reasons. The first is that all teams should be able to understand this framework. If they want to learn some details, they should be able to just open DataOps Assembly code in Git and understand how it works. Please remember that this framework is informal contract between developers and operation teams. So developers simply must know what are the constraints resulting from the agreed security model so that they can design the application to comply with the model. The second reason is, as any code, this code will suffer from some bugs, and anyone is welcome to fix them, or even contribute with new features through pull requests. Some example of new features is when there is a new component added to platform architecture blueprint, and there is some team that is that is early adopter of this new component, have figured out how to install the code on that platform, etc. So they commit this know-how to the central code base, and other teams can benefit from that. And finally, given it is implemented in Ansible, it is a CI/CD tool agnostic. So it can be executed from Jenkins, from Azure DevOps, or even from laptop. Okay, so that's all about this framework and about the theory. And now I would like to show how all these things work in practice. So let's assume you are members of application development team. Our application is called CityBike Analytics. So this demo is based on CityBike dataset. This is a real company based in New York, and they just rent bikes. The nice thing is that they also publish data about bike stations and their utilization every few seconds, and we can fetch that data via REST API. So we as a team are approaching end of our first sprint, and our business asked us to build a dictionary of stations as a sprint goal. Okay, so as development team, we have implemented Azure Data Factory pipeline, which consists of 2 stages. The first stage fetches data from this REST endpoint and materializes it on Azure Cloud Storage. The second stage runs a Databricks job, Databricks notebook, and that notebook has some code that is able to fetch that file from cloud storage and publish data to Snowflake stations table. Of course, there are many better ways to implement this requirement. Here we just wanted to show the case where really many components are used in order to demo our framework. So application team implemented all those artifacts, all those scripts, and organized the code following conventions behind installation package format. So we have Databricks notebook in Databricks folder, we have Azure Data Factory in ADF folder, and we have Snowflake scripts in SQL folder. Okay, so so if we go back to this CI/CD survey, you see that this first module, which automates configuration of application environment, finished without failures. So we can go to our to portal. Okay, let's log in, for example, to Databricks and see what this framework prepared for our application. So first thing we see that folder. Okay, you see that our application is called CityBike. We deployed from dev01 profile. So all these things were taken into account when building names. So we have this container. It's empty. It's empty now, right? So it's just a box. If we check the permissions, you see that it configured access control list. So only security groups assigned for this application can access that folder. Okay. If we go to admins, so we see those groups. We see that there's one member of admins, and this is this principal, service principal, created for this specific application to run scheduled jobs. Okay, so application environment is all about creating isolated box for our application. When we go to Snowflake, so let me refresh that page. It is a similar story. It will create administration objects for our application. So it created database for our application with some schemas. Okay. When we go to account, we will see that it created security roles. Again, I said that all that security model is consistent across our components. So in Databricks, we had security groups for admins, contributors, users. The same is here. And if we see, there is a technical account created in Snowflake, which will be used by the application to connect, application jobs to connect to Snowflake. Okay. The same is for Azure Data Factory, Key Vault, etc. So we have that secure box. So the last step is to just run the framework to deploy our code. So let me just paste. This time we will use not management module, but project module. Again, we'll provide the installation package path. So where is our application code? Where is the file describing the platform on which we want to install it? Which profile should be used, etc. It will take just a couple of seconds. So let me maybe take this opportunity, use this time to either answer your questions, or I will explain how this framework handles version control release of database changes, because it is in general quite challenging topic. So Tomek, do we have some questions?
To be honest, not yet, but if anyone have any question, please use the button. You have the raise hand. Oh, we have one. It's from Vitaly. Do you see it applicable in Azure Omni?
No. I mean, as I mentioned at the beginning, this is a very generic concept that can be applied, to on-premises, AWS, GCP, etc. This demo is about Azure, just to showcase it. But the concepts about generalizing, how people package the code, generalizing security model, parameterizing application code are very generic. So it's about adding additional modules for every component that you would like to cover by such a framework. I implemented something similar for on-premises previously with Informatica, Oracle, and Cloudera. Okay, so the same story, different components. So it's definitely applicable. It's not just for Azure.
Okay, so that's okay, cool. So I believe you display all the doubts. Okay, anyone else? I think I see that script finished. So maybe
yeah, the script finished. So we have both. We should have both. Our application environment ready. So the secure box, isolated box. And also now we should have our application code deployed. So when we get back to Snowflake, okay, let me change. Warehouse. Okay, I need to log out. Yeah, there's a funny thing, because as account administrator, I simply cannot see those objects that were created. So what I need to do, I need to assign simply myself as admin. I could use contributor or just user. Okay, but that role will give me all the permissions to see that application data objects. So let me log out and log in. Okay, I can take now this admin roles because I'm privileged to use it now. I can use Snowflake warehouse created for this application. You see the naming convention even is consistent. Okay. And you see that with that role, I'm privileged to see 3 tables in staging schema. Okay, the stations table is a table for our stations information. So something that our business asks us to prepare as a goal of the first sprint. The remaining 2 tables are auxiliary tables used by the framework that is used by DataOps Assembly. So we use Liquibase for version control of database changes. So Liquibase is a library, Java library used by Java web application developers for years. So it's quite popular. It's open source. This database changelog is auxiliary table which tracks all so-called change vectors that were installed. So if we have SQL commands that we want to deploy, execute, that database changelog will track which commands were already executed. So if we think about SQL command like DDL statement to create a table, okay, then we should have as many records in that table as change sets. So if we preview data, we see that there is 1 installation, this change set with that ID was already executed. So stations table is created. And if we execute that script again, it will somehow skip change sets that were already installed. Okay, so quite nice library. And we can version control all database changes, etc. Okay, so as you see, DataOps Assembly deployed application code. If we go to Databricks, previously that folder was empty, but now we should see okay, not yet. We see notebooks folder, and inside that notebooks folder we have notebooks implemented by our application team to address that business requirement. Okay, so if we go to portal and I open Azure Data Factory, which is our orchestrator, I have everything set up. So DataOps Assembly injected, replaced all the parameters with the parameters corresponding to this target platform. And I can basically, you see, I have pipelines deployed for my solution, and I can just run. This application is already deployed. So this automation deployment framework did its job, right? So now the application is deployed, and we can. So let's go to pipelines. I can click it. I can trigger it to run. Okay, all the parameters are injected when these things were deployed, so they were injected at runtime, and okay, the expected result here is that this pipeline will complete successfully, assuming that DataOps Assembly configured it properly. Okay, and once it is successful, we should see data in our stations table, which now is empty. Okay, so it should take like just a few minutes to complete. You see that the first stage, when data is copied from REST endpoint to cloud storage, is completed. Now, Data Factory will try to execute Databricks notebook on Spark cluster. We have URL to Databricks job. so we can track it. And it should take just a couple of minutes to complete. So let me maybe just switch to the last slide, which covers some challenges that you may face if you would like to, have something similar. So for me, the most challenging thing is that, as you see, analytics platforms are just a set of many components, there are many moving pieces. And every component, like Azure Data Factory, Databricks, and Snowflake, has slightly different characteristics when it comes how they support version control, what are the available, tools so that we can communicate externally, etc. Okay, so really, the question whether Azure, it works only with Azure, the answer is, as long as you know your component, let it be Informatica Power Center, you know how to deploy your code, you are good to add module for that component, and you can extend that framework to support such tools. But you need to simply know this component. Okay, you need to know whether it supports, version control. It is important because it doesn't. If it doesn't, then you will not be able to roll back to previous versions, right? Etc. If there are no, for example, if there is no REST API or some command line interfaces, then you will not be able to communicate with that tool from DataOps Assembly, right? So different components have different characteristics, and also every platform component has different growth rates. So there are some components that are very mature and stable. And there are components that are changing at furious rate. Think about Databricks. They release so many changes every month. They're really improving this service a lot, especially around security, that you really need to follow those changes and check if your automation scripts are still working. One example is they added access controls to access tokens. Right, so if previously your automation scripts were not assigning access controls to access tokens, then after that change was released, was made generally available, you simply started receiving errors that you have no access to this token. Okay, there are also components that would require some improvements that are not good enough but this is not going to happen soon. They don't have, community is not that active, etc. And also about, I try to emphasize that a lot, that automation of an application environments is really important to have this end-to-end coverage and really to reduce this end-to-end cycle times. But every component has different access control model or security model. So some services like Databricks or Snowflake have very granular access control. Okay, you can assign access to notebooks, to clusters, etc. But there are services that are not so granular. You assign access at the service level. Think about Azure Data Factory. If you you cannot assign, privileges to pipeline or to data or linked service. The same in Azure Key Vault. If you have access to this specific Key Vault instance, then you have access to all the secrets inside. So a lot of trade-offs and something that you must be aware when designing something like that. Okay, so let me, before we summarize that, let me go back to Azure Data Factory. Yeah, so success, this pipeline completed. And now when we go back to Snowflake, yeah, we see our data, which means that our team did a great job and achieved the goal of the sprint. Okay, so application is deployed. This automation application was highly parameterized. Deployment scripts. This framework calculated parameter values that must be injected for this code to work on this specific target platform. And we are able to, just to use this code. That code was prepared for us to work on this platform. Okay, so let me summarize. Okay, I have shown some framework which we call DataOps Assembly. Its goal is to accelerate delivery of business value by reducing cycle times. Okay, through automation. It's not necessarily a centralized solution, but it can work as such. But its goal is to automate all the tasks around setting up application environments and deploying application code. Automation requires us to think about, not to focus not just on a single project, but think across projects. So we have a chance to standardize a lot of things, like introduce consistent naming conventions, etc. Okay, because this framework is designed to be reused by many application teams. This is also an opportunity for platform admins or security specialists to inject some compliance or quality checkpoints, right? This is no longer a set of chaotic continuous deployment pipelines owned by project teams. It is something that is referenced by those teams. So finally, we have, like a single code base, which we can, shape the way we want and inject such things. Okay, the solution is quite generic, and there are some design principles that made it possible. One is that because we want it to be a reusable asset, we defined some simple set of conventions so that all the project teams are somehow obliged to package the code following those conventions. Because of that, we are able to enforce, some best practices like parameterize all the code, decouple code from infrastructure, etc. At the same time, this framework, works as informal contract between development teams and operations or platform admins teams. So platform admin teams for sure are owning this framework and have opportunity to inject all those quality checks and all they need to make sure that best practices are, applied. Development teams, on the other hand, can quickly check the code, especially around security model, and see what is expected from them. So imagine there is a new member of a team that has very little knowledge about, all those assumptions. So, it just needs to check this security model YAML file and understand what are the, security requirements for the application. So he knows how to design that application to comply with those, I would not call it constraints, but agreements. Okay, so this is very important. It's a shared code base with encoded know-how. So no longer reinventing the wheel. If you think how it should work, just create pull requests, contribute to the single code base, let other team members reuse that knowledge. Okay, and because we standardize and there is just single framework or single code base that is handling those deployments, it's much easier to scale operations teams, right? They don't need to, learn how applications implemented the automation scripts, right? You have just a a single code base. So every operations team members must just learn that single framework. Okay, so it's a short note about the DXA technology, and thanks for your attention. I'll be happy to answer your questions if you need such.
Yeah, thank you.